Hello everyone, this is our sensors and transducer labs. So in today's lab session we will perform an experiment which is related to measurement of pressure using Bourdon tube. So as we all know about Bourdon tube, so here the Bourdon tube we will use is a C-type Bourdon tube. So let's move to the experiment setup. You can see the aim of the experiment is to measure the pressure using Bourdon tube. So after that, apparatus required is nothing but C-type Bourdon tubes, which is a pressure gauge. Basically you can see this is the pressure gauge, and then displacement measurement by LVDT. Displacement measurement using LVDT we have already seen in the previous lab session, and a multimeter. These apparatus are very much needed for performing the experiment. So now come to the working principle part. This device, Bourdon tube, it was invented by Bourdon in the year 1849. The main idea behind this device is that cross-sectional tubing, when deformed in any way, will tend to regain its circular form under the action of pressure. That means you can see this is a C-type Bourdon tube. When pressure is applied on this Bourdon tube, it gets deformed and tries to regain its original shape. Due to this, whenever pressure is applied, we can measure the applied pressure from this sensor, and this is connected to a socket and soldered at one end with this socket where pressure is applied, and the other end or free end is this tip, which is sealed by this tip, right? This tip is connected to a segmented lever through an adjustable length link. This is connected to a segmented lever, right? So when pressure is applied to this Bourdon tube, it gets deformed, and this applied pressure will occur a change in displacement in LVDT, which is inside this setup, right? So you can see this Bourdon tube setup is connected through a wire with this LVDT setup. These are the winding connections behind this LVDT displacement measurement using LVDT kit, and this is the power supply. This plug is used for giving the power supply, right? So whenever pressure is applied, this applied pressure in this Bourdon tube is responsible for the change in displacement which occurs into this LVDT measurement kit, right? And then this displacement, which we can see in this digital display, will be measured in terms of in this digital display, and along with that analog output can be measured using this multimeter from these two terminals in terms of millivolts, right? So our input is pressure, which is in kg per centimeter square, you can see, and this kg per centimeter square applied input is responsible for occurring displacement in as I have shown you, and after that this displacement is then further measured by using multimeter in terms of electrical output, that means in terms of voltage in millivolts. So initially one thing I must show you, we can see here the display reading is initially it is showing like 11 but it is not 11, it should be 0 initially, as we have not applied any pressure initially. So If it is not showing 0, here is a 0 knob and a span. So we will not alter the span knob, we will use this 0 knob and we will adjust this offset or whatever error is showing, we will adjust it to 0 first, and after that we will start taking our readings. So from 0 kg per centimeter square to 10 or 12 kg per centimeter square, up to this much reading we will take for our observation table, and we will show you how this is giving us the output in terms of voltage, right? So let's go for the practical session. It is the circuit diagram. You can see whatever I have shown in that Bourdon tube. It is the sketch, brief sketch, and this needle is used for measuring the pressure in terms of kg per centimeter square, and this is the tip which is associated with this adjustable link with this segmented lever, and this is the socket which is soldered with this socket, the Bourdon tube which is soldered with this socket, and the pressure is applied in this end and this gets deformed, right? So we will measure this applied pressure, right? And you can see this is the observation table. Pressure gauge position or pressure applied pressure, whatever you can say, it is in kg per centimeter square. Display position, that means LVDT measurement kit, whatever the digital display, it is showing in mm, the unit will be in mm, and output voltage it will be in millivolts. So one by one reading we will take and we will prepare the observation table, right? So here initially it is at 0 and the display position we have adjusted to 0 mm reading, and initially multimeter is showing 0.30 millivolts, right? At 0 it is showing 0.30 millivolts. So I am applying pressure now. I am applying pressure here from 0 to 1. Now it is in 1 kg per centimeter square, and display reading it is showing 0.1 mm displacement, and the output voltage is 1.13 millivolts, right? Pressure gauge, it is 1 kg, and here it is 0.1, and output is showing 1.13. Now at 2 kg per centimeter square it is showing 0.2, and the multimeter is showing 2.16 millivolt. Now it is at 3 kg per centimeter square, and the display is showing 0.3 mm displacement, and the output is 3.45 millivolts, right? Now it is at 4 kg per centimeter square, and the displacement is showing 0.5 mm, right? And the output voltage is showing 5 millivolt. Now I am increasing further at 6 kg per centimeter square. It is showing 6 mm displacement, 0.6 mm displacement, and the multimeter is showing output as 6.31 millivolt. So likewise, from 0 kg per centimeter square to 7.6 per kg per centimeter square, we have taken few readings, as I have shown you already few initial readings. So likewise we can take such readings up to 10 or 12 kg per centimeter square also. So we have taken only initial 10 readings. As you can see here, the final display reading I have taken is 1 mm was our final displacement, and here it is the observation table, whatever we have got, from 0 kg per centimeter square to 7.6 kg per centimeter square, and along with that the displacement, change in displacement occurred from 0 mm to 1 mm, right? And this is the output voltage. So likewise we can take the reverse reading also. From here we can initiate the releasing of pressure and decrease the applied pressure, as well as we can measure the change in displacement from here in reverse direction also, as well as we can measure the output voltage. That means the output in terms of voltage in millivolts. So this is the whole idea of the experiments. So in this way we can measure the pressure using Bourdon tube, as well as an displacement measurement kit used by using LVDT. So using these two kits associated with each other, we can measure any applied pressure. So thank you.